Students, greetings of the day. So today we'll talk about spherical mirrors part 2. Okay, right here once part 1 also, once you can cross check last 10 minutes and then go for this video. Yeah, thank you all.
Light rays are coming and they will reflect to our eyes, both right and left side. So red view mirror we are using as convection. The reflector we are using and dead disc also we are using for seeing the images by using this property, virtual magnified direct image property. Okay, this is what. Next we see for mirror equation and the radius of curvature focal relation. For small aperture mirrors, what is the aperture? Aperture means this region where light falls. This region where light falls is called aperture. For small aperture mirrors, okay, we are going to do is R is equal to 2F. R is equal to 2F means this is called PC is equal to R. Pole to focus is called focal length. So R is equal to 2F means this F is midpoint of PC. F is what? Midpoint of PC that we are going to see now. These two images drawing for everyone. Two images drawing over everyone. Wow. For small aperture mirrors, R is equal to F. They are saying, no? If I take light rays from sun or another object, like parallel rays, where they will convert the net focus now? Yes or no? For small aperture mirror and paraxial condition, paraxial rays. So they are very close to acting as a pinpoint axis. The pinpoint axis. On this light is and this angle of reflection. So you can say when this angle is theta, this is normal, taking unit m. This also angle of reflection. I is equal to r, theta is equal to theta. Now when this also theta, right? Now this entire angle is 2 theta. So this also almost right. 2 theta. Or else in this triangle CMF. This is the interior angle, this is the interior angle, the exterior angle. Exterior angle is sum of opposite interior angles, so 2 theta. Okay. Now, this is small aperture mirror. No, this if I drop a perpendicular like this, say from D. For small aperture mirror, this MP is equal to MD. Curvature is very small. Aperture is very small, almost straight line it is, almost straight line. Almost what? Straight line. Now, here you see, this distance is PC, radius of curvature, this distance is focal length F. In this triangle pattern for small angles, tan theta is equal to opposite side, MD by adjacent side, okay, DC or C. MD is equal to MP again take now. C is very small means the DIP will coincide. So I can take PC. What I am saying is if this mirror is of very small aperture, M and D, no, MD, D and P coincides. So in this triangle, if I take CMD, in CMD triangle, what I am writing here, tan theta is opposite by adjacent. Opposite MD is equal to MP. A small aperture mirrors. This adjacent side is PC. Right? Similarly, in this triangle is FMD. In FMD triangle, tan 2 theta if I take, how much tan theta? Opposite side is MD or MP. Adjacent side is FD. But FD is equal to FP I will take. They are coincide very small కాబట్టి. అర్థమవుతుంది మీకు? Right? So this is MD by. If I write perpendicular is very small graph, so B and D will coincide. FD is equal to FQ or PF as you wish. This is equation 1. This is equation 2. So 2 implies for small aperture, the angles are very small, right? But because we are talking about which rays? We are talking about paraxial rays. Angles are very, very small. When angles are very small, For paraxial rays, theta is small. Okay, in that case, you can say tan theta is equal to theta. Tan theta is equal to theta. For smaller angles, you can make approximation radians. If I take this value as 2 theta, so 2 implies 2 theta is equal to mg by pf. So 2 times theta value from first equation, tan theta is what I can take md by pc. md by pf. md get cancelled. So 2 by pc. By sign convention, pc. Right is going left to right. pc is equal minus r. Okay, this is 1 by pf. P to f. Right ray going left to right. You're going from pole to focus. That's what. Minus f. So you can cancel these. So you can get r is equal to f. Therefore, for small aperture, not only concave, you can also prove for convex also. Okay, for small aperture mirrors, axial rays only. Okay, mirrors, lenses, they are very small in size. The angles are very small they make. Okay, under that condition only we'll apply this. Other Gaussian optics principles you have to take. Angles should not equal, other equations will be derived. Mirrors, radius of curvature is twice the focal length. This the board point of view, this derivation is important. Comparative point of view, result is important. Okay. Yeah, if you finish this, let us go for mirror equation and some numericals. Tomorrow exam Sunday, huh? Yesterday over?
Yeah.
It didn't come? But on your simple logic here, theta is exterior angle in the triangle is 2 theta. Alternate angle is 2 theta is equal to 2 theta. Tan theta you have taken 55. So radius of curvature twice the focal length. And next is mirror equation. What does mirror equation indicate? Spare of this part? Writing over girls. And next we have mirror equation. What does this equation use? Is for considering any mirror that doesn't matter, concave or convex or generally. So for example, if I compute a complete sphere, center of curvature, focus is pole. Say focus on mirror is some F. If I place an object, okay, if I take an object, say A, it will form its image. Where is the object? B and C. Where the image will be? Between C and F. So you can take one parallel ray, passes through focus. Underline ray, extending it to pole. Bounces back the same angle, one angle eccentric. Image will be C and F. This is B dash. Okay, say angle of incidence is I. R log equal to I. Now, whenever the object distance if I consider from the pole, this is the object distance Q, and this is the image formed here, this is the image distance, right? So, when I consider this light and reflecting in this way, this light if I take on the meeting here, directly real image we are getting. Now, the mirror equation relates this object distance, image distance, and focal length. And what relation we have? Everyone knows? 1 by f is equal to 1 by v plus 1 by v. You can prove by geometry this one. How? You can take the triangle side. So if I take this triangle, which triangle if I take this ABP, A dash B dash P, A dash B dash P triangles. They are similar triangles. Why? This angle is 90. This angle is 90. This angle is equal. This angle also equal. Okay, so they are what? Similar triangles. Ratio remains same. If I take A dash B dash by AB, A dash B dash by AB is equal to, I can write B dash B divided by BP. Equation number 1. Similarly, I have to relate what? Focal length. So B dash. Now I can take here one more point. These two triangles over now. Two triangle this one. Here in this triangle, B dash F C and so this is M. So B dash B C B dash F C. Focus no? Focus long. B dash F C and M F P. M F P triangles. And parallel is already almost you can take if I draw normal just to coincide taken. Like before you were seeing like die by D. P and D are coinciding. So approximately this is also a triangle. For smaller aperture, for parallel conditions, is M if I draw perpendicular these two coincides. Nearly a straight line this is. When you compare these two also, you can take this as right angle, this is also right angle, and this angle is equal to this angle. And by congruency, what? Rule here, but I can write that. B dash F by B dash F by C. B dash F by P F dash. Base to base is equal to height to height. B dash divided by height MP. This is A dash B dash by MP is equal to AB. MP is equal to what here? AB. Equation number 2. Find. Hello, geometry. By congruency of the triangles, you can write now. First, you have taken ABB and A dash B dash triangle you have taken. Next, you want to reduce the focal length also. So B dash FC and M have three triangles. The ratio of the triangles side lengths are equal. Now, from these two, what do you get? 1 and 2. 1 and 2, when these are equal, B dash P by dt is equal to B dash F by PF. PF. Step now. This is pole. PF. B dash P. What is B dash P? B dash P is distance of the what? Image. B dash P is distance of the image. DP. What is DP? DP is distance of the object. So distance of the image. Distance of the image is B. But sign convention, right always left to right. B dash P is negative. So minus B. By always don't write sign convention right. BP. BP is object distance U. Right traveling left to right, you are going right to left. This is minus U. This will be B dash F. B dash F I can write as B dash P minus PF I can write. B dash F I can write as B dash P minus PF. And by PF is focal length. Focal length, your right ray is going like this, your measuring focal is this way, negative. This is minus F. So, by simplify, of course, this gets cancelled. This is B by U is equal to now B dash P. B dash P is what distance? Image distance, which is negative minus B minus PF. PF is focal length. I take going like this. Pole to focus, we are going left side, negative. So minus F divided by what do you have? What we have? Minus F. When you simplify, B by U is equal to minus B plus F by minus F. 1 time minus BF is equal to minus B plus QF. Now, take this one this side. You can write UF plus BF is equal to U. UF plus BF is equal to take this one left side. Depend with UV either side. So we have UF, not take F common. UV or 1 by f is equal to by v plus v by u. So 1 by f is equal to 1 by v plus you can take for not only this real image, you can take for virtual image, concave mirror, convex mirror, virtual image. Also, you can draw the ray diagram. You can take the congruency property of triangles. Okay, similar triangles. Take the ratio to derive this. So I have just taken ABB triangle and this one F dash LP triangle and B dash B triangle, FPF triangle. Ratios I equated by using sign convention I substituted. And I am finding relation between object distance U, image distance V, and focal length F, which we call this relation is known as mirror equation. Whenever you are using this formula for solving problems, you have to use sign convention mandatory. Okay, everyone. Fine, right?
Yes.
So based on this, you have problems. 1 minute. Yeah. Question round over. An object of 5 centimeter height. An object of 5 centimeter height. An object of 5 centimeter height is placed at distance of 15 centimeter. An object of 5 centimeter height is placed at distance of 15 centimeter from a concave mirror. Place a distance of 15 centimeter from a concave mirror of radius of curvature 20 centimeter. Of radius of curvature 20 centimeter. Find the size of image. Find the size of image. Find the size of image. Five centimeters. So height of the object is 5 centimeters. Is placed at distance of 15 centimeters. Object distance 15 centimeters. For real images always object is negative, no? Minus 15 centimeters. For a concave mirror of radius of curvature given. Radius of curvature is PC value given. Wherever we place object, no, like this, go like this. PC is negative. So no, R value how much given? 20 centimeters. Or of course negative, focus also comes negative here. But R value how much? R is equal to here. 20 centimeters. LCP how much? 10 centimeters. Concave, no, concave mirror focus negative or positive? Concave mirror focal length is negative. If you want, you can write it after. So concave mirror focal length is negative for real object and convex mirror focal length is positive. Now, lastly, size of the image. Now, first we find where is the location of the image. Focal length is known to you, object is known to you. From mirror equation, what you can write? From mirror equation, 1 by f is equal to 1 by f plus 1 by the sign convention. 1 by focal length for concave negative minus 10. You have to find out the image. See in this formula, for whose value you want to find. Don't substitute sign for that. We don't know where the image is formed. Only known value substitute here. Plus 1 by u. Object distance is not 15 centimeter, but negative left side. So 1 by v becomes 1 by 15 minus 1 by 10. 30, 5 to the 5 to the 5 to 3 the 5 to 6 30 no. 2 minus 3 is 1 by v. So v will be how much? Yeah, we will be minus 30. Minus come is meaning क्या है? It is left side of the object. So focal length how much? Minus 10 centimeter. Focal length is 10. So image is what? 30 centimeter distance अगर form आएंगे. So definitely same side means real image only. So it has formed at a distance of 30 centimeters. Okay. Now what is magnification formula for mirrors? magnification formula for mirrors, you can do same geometry, height of the image by height of the object. Now in this position, object is placed at distance of 5 cm and focal length is 10 cm. This what kind of image will form?
Sir,
Image is B and C.
yeah.
You can say directed this is height of the image, this is height of the object. Okay, object height is positive, image is negative. Okay, negative is coming, real image. Okay, and you can also do magnification formula is mirrors is minus d by u. How much magnification? Same mirror equation derivation ఉంది కదా అక్కడ రాసుకోండి height of the image by height of the object ratio తీసుకుంటే మీకు minus d by u వస్తుంది. Okay, minus d by u and minus d value how much? This formula is important for mirrors. Yeah, d value is minus 30 by u value is minus 50. This is negative. Negative for what kind of images, friend? Negative for what kind of images? Magnification is negative for real images. And magnification magnitude how much to know? This will be height of the image by height of the object equal to. So height of the image is 2 times height of the object. And height of object how much given? 5 centimeter. This is 5. This is equal to 10 centimeter. If you write here with negative symbol, nothing is wrong. Negative का मतलब है image is inverted. What the meaning of negative here? Image is
Real.
inverted. No?
If negative sign,
Negative sign you can say real also as well as you can also say inverted. Both the cases. Okay?
yeah.
Question now. An object is placed and you can write down there question Newton's formula and Newton's formula. Okay, what do you write? Newton's formula for spherical mirrors. Next heading. Question only, but you have a question of the formula. Okay. As question we are doing this Newton's formula. The focal length is equal to root x1 x2. Now what is this possibility?
Sir,
You see, in generally we measure distances from pole. In this formula, our derivation, we measure distances from the focus. Say an object is placed at distance of x1 from the pole. Sorry, focus. And image is formed at distance of x2 from focus. What are the actual portions of objects from? Object distance generally what? General formula is from pole. But if an object is placed at distance x1 from the focus, image is formed at distance x2 from the focus, then
Sir.
root x1 x2. Emandra?
sir,
Hello?
yes, sir.
Fine, I am near on mobile only, right? Now see, what will be object distance now? Object from pole is called. Pole to focus is f plus x1. Negative minus f plus x1. Object distance. What image distance will be now? Where the image is formed? From focus at x2 distance. Image distance is what? f plus x2. Now, if focal mirror is 1 by f is equal to now 1 by f is 1 by v plus 1 by u. Simplify చేయండి అని ఎంత చెప్పండి నాకు మీకు అంత రావాలి అది చేయండి అది concave mirror if you take concave or convex according you can take. If I take here focal is for concave and negative no minus 1 by f is equal to 1 by v. V value is minus of f plus x2 and plus 1 by u is minus of f plus x1. Minus cancel. So 1 by f is f plus x1 plus f plus x2 f square plus f x1 plus f x2. Simplification చూడండి జాగ్రత్తగా. Following రే. Now if you simplify, what you will get? F into f square. Actually f plus f 2f, 2f into f is right, 2f square. F plus f 2f, 2f into f is f square, 2f square plus f into x1, f x1, f into x2, f x2. Take this to the left side. F square plus fx1 plus fx2. So this to get cancelled now. Even no? x1 x2 is including. Where will have x1 x2? Denominator, no? Yeah, we have x1 x2 in denominator. So this will be plus x1 x2. You can cancel this term on the other side. Take the right hand. F square is x1 x2. So f value how much now? Root x1 x2. This formula we are calling as Newton's formula. What formula, sir? So only thing is, if an object is placed at distance x1 from the focus, if image is formed at distance x2 from the focus, and focal length of the mirror directly given as root x1 x2. Any mirror you can take. But can you place for a virtual convex mirror ray? Convex mirror you cannot place object from where? Simple. You can place here convex mirror is also distance disclosure focal length is disclosure. Center of curvature is this one. This is focus. If I place an object here, this is pole. So distance you can measure from here by this you are measure. You can this coach with image of course image always between P and F. What's correct? So again this distance is x2 you can take. Then also it is valid. Then also it is valid. I mean measure focus on chestunna ee formula value avutadi. F is equal root x1 x2 formula.
Yes.
Keep in mind, focal length of a mirror, focal length of a given mirror is always constant, right? Focal length of a given mirror is always constant. It doesn't depend on the surrounding medium. If I have a lens, mirror of focal length of 10 cm, if I immerse in water, its focal length remains the same. It will not change. It depends on what? Radius of curvature. R is equal to here. Next point, triangle. Focal length of a mirror. This is what derivation, everyone? Focal length of a mirror depends only on its radius of curvature. Focal length of a mirror, any mirror, convex or concave, doesn't matter. Focal length of a spherical mirror, what I mean to say is here. Focal length of a mirror depends only on its radius of curvature, not on the surrounding medium. That is it. F is F. Means where is the A? If I immerse this mirror in the water, okay, it is F dash. F dash also equal to F. It will not change. It will not change. Why? Because radius of curvature is same. R is equal to F. F is depend on only R. R is constant, so F also constant. It depends only on the curvature. So the focal length of a mirror depends only on its radius of curvature, not on the surrounding mediums. Very important point. Write one question now. If a luminous point is moving, if a luminous point is moving at a speed v naught, a luminous point is moving at a speed v naught towards a mirror. This mirror, a point object is there. velocity v naught. Okay. So luminous point is moving at a speed v naught towards a spherical mirror. Towards a spherical mirror. You can take concave or doesn't matter. Then this one. So a luminous point object, okay? A luminous point is moving. Luminous means glowing. Okay. So glowing point is moving at a speed v naught towards a spherical mirror of focal length f along its axis. Along its axis. Along its axis. Find the speed of its image. Find the speed of its image. Find the speed of its image. Just right. How to find? See here, as the object is approaching the mirror, object distance is changing. Focal length is constant. So image distance will also change to make object, focal length constant. See here, by mirror equation, 1 by f is equal to 1 by v plus 1 by v. It's always constant, man. U is changing. Definitely v will change. So that f remains the same. So if a difference is changing, this is constant. Difference with respect to time, but because object is changing, v meter per second, v naught means what? In 1 second, distance traveled is v naught. Therefore, differentiating above expression. Differentiating with respect to time. This is what, right? Constant now. Differentiation of constant is 0. 1 by v is minus 1 by v square dt by dt. Why? Because v power minus 1, x power n into x power n minus 1 into dt by dt as well. Avuna kada? Similarly, plus 1 by u is again minus 1 by u square du by dt. What is dd by dt and du by dt? Du by dt is the rate at which object distance is changing. dv by dt is the rate at which image distance is changing. The rate at which object distance changes is called speed of object. The rate at which image distance changes is called speed of image. Therefore, I can write down how speed of image is asking. So dv by dt, take this left side. 1 by v square is equal to minus 1 by u square into du by dt. So now dv by dt is equal to minus v by u into whole square into du by dt. The rate at which image distance changing in the mirror equation, v indicates what? Image distance. The rate image distance is nothing but velocity of the image. Velocity with respect to whom? With respect to mirror. Mirror is fixed here. Mirror is what? Fixed. So velocity of the image with respect to mirror it is equal to minus v by 2 whole square into du by dt is the rate at which object distance is changing. That is called velocity of the object. Velocity, this is V in capital V. Capital V is velocity of image, this capital V is velocity of object. So you can also find out here D value you are in the substitute option in terms of focal length. Sometimes you may ask in terms of focal length distances. Ideally, this formula. 1 implies 1 by V value is equal to 1 by F minus 1 by V. UF minus. So V will be UF by U minus. And if I take 1 by U, 1 by U will be 1 by F minus 1 by V. V minus F by 1 by U. So U will be VF by V minus. U is V is UF by U minus F. If you want U is VF by V minus F. So V by U, what will you get? V by U. V by U whole square into Japani. V by U will be how much? V by U. V by U is V minus F by Here first. You can substitute this over here. Then what is the formula you will get? Just for sometimes it will focal length. Then velocity of the image. Velocity image is minus indicates that when object is approaching leftwards, right? Minus indicates image is approaching rightwards. If object goes away, image moves towards the mirror. They are opposites. Already we have seen in ray diagrams. An object is what? Approaching towards the mirror. Image is moving away from the mirror. Both are in opposite direction. No, that was just negative sign indicates. Image and object they are traveling in what directions? They are traveling in what directions, right? Opposite directions. Following. Arey Babu. Hello. Can you hear me? The distance of the image is minus d by u whole square into velocity of the object. And sometimes the graph will be asked, the graphs on UV graph. 1 by V graph, 1 by U graph, UV graph. Let us draw it now. Yeah. Next. This one over everyone. Hello. మాట్లాడేంద్ర ఎవరు కూడా ఉన్నారు అసలు వెళ్ళిపోయారా नहीं वरुण
Yes, sir.
वरुण
Yes, sir.
understood now
Yes, sir. Understood.
yeah graph for concave mirror next write the question draw draw 1 by V versus 1 by U graph for concave mirror. Yeah. For real image, for virtual image, both you can draw it. For real image, for virtual image, both you can draw. First we will take real image and then take virtual image. So take first real image. For real image, object distance negative and image distance also negative. Of course, focal length is always negative. Yes or no? Now in this mirror equation formula, 1 by minus f is equal to 1 by minus c plus 1 by minus 2. This gets cancelled. We want to draw a graph of 1 by u versus 1 by u. 1 by v is equal to minus 1 by u plus 1 by f. For real image, object distance negative, image on the same side is forming. Same side negative. Third first is substitute the signs here. Then 1 by v is minus 1 by u plus 1 by f. Now draw the graph. How to draw the graph? So if I draw the graph, it will look like this. 1 by v on y-axis, 1 by u on x-axis. This is y is equal to minus mx plus t form. In which form it is? Y is equal to minus mx plus c. Minus is negative slope and y-intercept is positive. Y-intercept, this is y-axis, x-axis. Y-intercept is positive. It's negative slope. Slope is negative. Angle up to the angle. This intercept is positive. How much value intercept is here? C is 1 by f. And slope how much, right? Slope ఎంత ఉంది? Slope is 1 by f. Slope is what? Slope is 1 by u. Understood? Now, similarly, we draw the virtual image and UV graph. In the afternoon, I will tell. Okay, I will take the class. చెప్పేస్తాను. ఎన్ని గంటలకు ఉంది? సేమ్ ఫ్రమ్ ఈక్వేషన్ యూ కెన్ అనలైజ్ గ్రాఫ్ అంతా మించి ఏం లేదు. జస్ట్ అప్లికేషన్ పార్ట్ చెప్పాల్సిన అవసరం లేదు. బట్ జస్ట్ ఐ హావ్ షోన్ యూ వన్ బై వన్. ఇఫ్ ఇట్ UV గ్రాఫ్ విల్ బి వాట్? UV పారా రెక్టాంగిల్ హైపర్బోలా వస్తుంది. UV గ్రాఫ్ ఎట్లా వస్తుంది? UV గ్రాఫ్ గ్రాఫ్ ఎట్లా వస్తుంది? Because f is constant కదా. So f will be UV by U plus V. F constant. That means where UV డ్రా చేస్తే rectangle hyperbola వస్తుంది. Okay. This is what spherical mirrors pin problems ఉంటే మీకు magnification పైన. Okay. So you can do the example questions on the material and all. Level 1, level 12 చేసుకోండి. So today still time is there. Tomorrow not 9 o'clock exam. At what time is tomorrow exam?
9, sir.
Yes.
9, sir.
Okay, fine. This is your syllabus, right? Spherical mirrors, plane mirrors. Your refraction schedule on the refraction Monday not start the refraction. Sorry, no? Monday few more problems I will do on this one. Then we go start to refraction part. Sorry, no? Shall I end the session? Yes, everyone.
Yeah, thank you all students. Fine.